Yes, in this session, we will discuss about dynamic memory management. Okay, so this is also termed as dynamic memory allocation. So generally, what is the problem with this static memory allocation? Okay, so if you consider in C language, we often use this static memory location. An example for static or fixed memory location is, let us suppose you have declared int a of 5 and then semicolon. So this actually represents, it is going to allocate 5 contiguous memory locations. It will allocate 5 contiguous memory locations just like this: 1, 2, 3, 4 and 5. Now this location is representing a of 0. So this is a of 1, this is a of 2, a of 3 and this is a of 4. Like this there will be 5 contiguous memory locations. Now the problem with static memory location, so this is considered as a static or fixed way of allocating memory. So the problem here is, if you want to store 10 elements, you cannot store because the memory is allocated only for 5 contiguous elements. Okay. Suppose if you are using only 2 elements, then remaining memory location will be wasted. That is 5 minus 2 equal to 3 locations will be clearly wasted. Memory is wasted for 3 locations. Okay. So this is a problem with static or fixed memory location. Okay. Now to overcome this, in C we have dynamic memory allocation, where you supply value dynamically and the memory is allocated based on the value that you have supplied. Okay. So for example, you are taking n value at runtime and it can create n contiguous memory locations as per your requirement. Okay. So that is considered as dynamic memory allocation. And here there are different dynamic memory allocation functions available in C. Okay. So those functions are, first one is malloc function. So this is malloc function. Okay. And using malloc, generally we allocate whatever requested size of bytes by the user. Those many bytes of memory will be allocated and the pointer will be pointing to the first byte of the memory. So which we will be discussing shortly in detail. Next, another one is calloc. So this is another dynamic memory management function. So where it is going to allocate space for an array of elements, and it will also initialize all these elements to 0. Okay. And it will return the pointer of the first location. Okay. And then coming to free. So this is used to basically deallocate the memory space which is allocated previously. So you might have already allocated some memory space using malloc or calloc, but using free, you are going to deallocate the memory that is allocated using malloc, calloc. Okay. So next, coming to realloc. So according to realloc, whenever the dynamically allocated memory space is not sufficient, then you have a chance to reallocate how much you want. Okay. So for that purpose, reallocation function will be useful. That is realloc function. So it will basically help you to modify the size of whatever allocated space you have done previously. Okay. So these 4 are the dynamic memory management functions. Okay. So let's discuss in detail about very first function, which is malloc function. Okay. So as this malloc function is going to allocate a block of memory, right? It will allocate whatever block that you specify, how many blocks you want. Okay, so those many blocks of memory it will allocate. Okay, and consider how you are going to allocate this and how the pointer will be pointing to the first location. So the general syntax of the malloc is ptr is equal to, okay, data type star. You have to specify it like this, data type star, and then malloc of byte size. So this is the general syntax of using malloc. Okay, now let us consider an example here. So here I'm going to consider a pointer variable called int star p. Now p is equal to int star, okay, I'm applying malloc here, int star malloc of byte size. Okay, let us suppose I'm writing like this, 5 into size of int, 5 into size of int. So this is going to basically allocate 5 into size of integer. How many bytes? It will return the byte size, right? So size of integer is basically 4 bytes. Then 5 into 4 is equal to 20. So this will allocate 20 bytes of memory space, and this will be pointed by the pointer p. Okay, pointer p will be pointing to this very first location. So let me show you how this is going to be done. Okay, so first of all, it is creating 5 contiguous integer memory locations. So 5 contiguous integer memory locations. So this is 1, 2, 3, 4, 5, like this. Okay, and consider the very first one is a location called 1000, for example, and this will be 1004, and this is 1008. Okay, this is 1012, and this is 1016. So like this, 5 contiguous memory locations will be created, and p will be a pointer holding the base address of this particular array. So p is a pointer, okay, and this is pointing to the base address just like this. Okay, so now you can observe 5 contiguous memory locations are created. Okay, and p is a pointer which is pointing to the base address of the entire array. Okay, so this is done with the help of malloc. Suppose if memory is not allocated, in that case p will be pointing to null. Okay, suppose there is no memory space of 5 contiguous memory locations. In that case it has to return null. So generally, okay, 5 is a small number, so it will allocate, but let us suppose you are given very large number, okay, and that contiguous memory space, okay, so it doesn't have that much of memory space. In that case it is going to return null. Okay, so this is about malloc. Now quickly we will see about one more function. Okay, in order to write any program we require another function, which is free function. Okay, so I'll first discuss about free function. Why? Because you have to deallocate whatever memory that is allocated by you, right? So it is used to deallocate memory which is allocated using pointer. deallocate memory. And if you look at the general syntax of free here, so you can write it as free of PTR, writing free of PTR. So it will free the memory allocated by the pointer PTR. Okay. So now let us consider the same example which you have considered already, that is the int star p. P is equal to int star malloc of 5 into size of int. Now after this you want to deallocate whatever memory that is allocated. So you can do this with the help of free by writing free of p. Okay. So this will deallocate the memory which is allocated using pointer p here. Okay. And in order to make use of these functions, okay, which are part of dynamic memory management, so you need to include its corresponding header file, which is malloc.h. Okay, so you can include malloc.h. So let us consider writing a program here. So where you are going to allocate memory with the help of malloc. Okay. So first include the standard header file, which is a stdio.h. Now you want to use this malloc functionality. So for this purpose include malloc.h. So this is malloc.h. Okay. Now using main function, okay, first I am taking a pointer because you need pointer to point to the base address of the memory allocated. So int star iptr, okay, and n is a variable and I is another variable. I'm using I for basically iteration purpose, and n is representing how many elements you want to store. Okay, so let us allocate memory based on n value using malloc. So first we can prompt the user to basically enter n value, okay, or ask the user to enter number of elements. So how many elements are there? You have to enter. So after entering the number of elements, then using scanf statement we can read that value into variable n. So that is percentage d address of n. Percentage d address of n. Okay. So using this n value, okay, so we can allocate using malloc, where iptr is pointing to the base address of the memory allocated. So iptr is equal to, now it has to typecast to integer pointer because we are trying to store all integer values here. Okay, and allocate using malloc. How much of bytes you are allocating? So which is nothing but n into size of integer. Size of integer. So this will allocate memory for n integers, right? Okay. And after this, using n value, you can start storing elements with the help of scanf statement. Okay. So let's see how this can be done. Is first of all, I'll prompt the user to enter these many elements because you have already taken n value. So you have to supply n number of elements. So I'm writing enter percentage d elements. Then user starts entering those many elements. Okay. And once those elements are entered, okay, then you have to start storing it into the memory allocated using malloc. So this can be done with the help of a loop variable I equal to 0, I less than n, I plus plus. Okay. And using scanf statement you can store, right? So that is a scanf percentage d So this is a IPTR plus IPTR plus I. So the base address is pointed by IPTR. Okay. When I value is 0, first it will store the element in that location. Then it is incremented by I. It means it will go to the next location and store the next element. So this is how scanf works here. Now we want to display all the elements which are stored here right now. So you can write a printf statement saying the list of elements. Okay. The list of elements. Okay. Now using for loop you can iterate and display all these elements like I equal to 0, I less than n, I plus plus. Now start displaying these elements with the help of printf statement. Okay. So where you want content inside the memory location, so use a star because you're trying to access with the help of pointer variable IPTR. So star of IPTR plus I, using which you can access the content inside each of this memory location which is pointed by IPTR. Okay. So once the accessing is done, you just need to deallocate the memory which is already allocated using malloc. So for this purpose you have to use free of IPTR. We are deallocating the memory which is allocated using IPTR, that is using malloc. Okay. So this is the entire program. Okay. So let's see how this program is going to work first of all. So in the output screen, generally it will ask you to first enter number of elements because program execution starts from the main function, and here it is printing this statement, right, which is enter number of elements. So let us suppose you have entered a number of elements as 5. Okay. Then what happens here, it will create 5 contiguous memory locations. Okay. So consider here how this creation happens is using IPTR. Okay. IPTR will be the pointer which will be pointing to whatever memory that is allocated using malloc. Okay. And here we are considering n is equal to 5, which means it will create 5 contiguous integer locations like this. Okay. Now malloc has to typecast. After that we are performing typecasting into integer. Okay. By default it will be a void pointer, okay, or generic pointer. So that's why you need to type convert it into its corresponding data type. As IPTR is an integer pointer, okay, you have to type convert into integer. So once the memory is allocated like this for n value equal to 5, okay, then if you look at the next statement here, enter %d elements, which means it will prompt in the output screen saying that enter 5 elements because n value is 5 here. Okay. Now you can start entering those 5 elements. Let us suppose you have entered 10, 20, 30, 40 and 50. These elements are entered. So then these elements will be stored one after the other here, 10, 20, 30, 40 and 50. So why? Because since I value is 0, okay, so IPTR plus 0 will be representing this location. Okay. So consider this is address 1000, this will be 1004, this is 1008, this is 1012, this is 1016. Okay. Now using IPTR we are pointing to the base address. Okay. Now we are going to display the list of elements here. Okay, so finally it is going to display the list of elements. So what are the elements that you are displaying? Is using star you are trying to access each and every element here. So the same elements will be displayed when I equal to 0. This element will be displayed in the next iteration when I equal to 1. Okay, IPTR will be incremented by 1 memory location. So this element of 20 will be displayed, and so on like this. You are able to display all these elements. Okay, and finally free of IPTR. Okay, so which means it is going to basically deallocate the memory which is allocated using IPTR. So you are no longer will be able to access that content. Okay, so this is how the malloc works and also free works. Okay, so this is how you can allocate memory using malloc and deallocate the memory using free in dynamic memory management.